the smart grid now, aging assets and lack of circuit capacities. So you can observe nowadays day by day increasing energy consumption, so generation need to be expanded and transmission distribution need to be expanded. So in lack of circuit capacity, it need to be replaced or need of replacement, because here need to refurbish the transmission and distribution circuits to innovate with the new designs and operating practices because of lack of capacity. So here in many countries what they do, the overhead line circuits needed to meet the load growth, if any increase in the load. Okay, the overhead line circuits need to meet load growth or to connect a renewable generation have been delayed for up to 10 years due to difficulties in obtaining environmental permits or rights of way in other countries. Okay, in many countries they use a overhead line circuits needed to meet the load growth, or they need to connect a renewable generation that have been delayed for up to 10 years because there are difficulties in the rights of way and environmental permits. So therefore some of the existing power transmission and distribution lines are operating near their capacity and some renewable generation cannot be connected. This calls for more intelligent methods of increasing the power transfer capacity of circuits dynamically and rerouting the power flow through less loaded circuits. So here the main important thing, remember that transmission and distribution need to refurbish. Okay, that need of replacement and the design should be changed because lack of circuit capacity. And here in other countries overhead line circuits need to meet load growth or they need to connect to renewable generation, but they have been delayed for 10 years because of difficulties in a rights of way and environmental permits. And here some of the existing power transmission distribution lines are operating near their capacity and some renewable energies we cannot be connected. This calls so the more intelligent methods need to be used for in order to increase the power transfer capacity of circuits, and that is rerouting the power flow through less loaded circuits. Okay, this is about the and lack of circuit capacity. Why we need a smart grid means, why to implement the smart grid means, this is the first. And second is a thermal constraints. What do you mean here? Existing transmission and distribution lines equipments are the ultimate limit of their power transfer capability. Here if we use a excess current, okay, when power equipment carries excess current, carries current in excess of its thermal rating, it becomes overheated and it loses its insulation. Okay, that will lead to a reduction in the life of the equipment. So if the excess current flow it will be overheated and that will lead to a reduction in the life of the equipment and it loses the insulation also. So here ultimate limit of the power transfer capability in this thermal constraints, you remember the ultimate limit of their power transfer capability, and you remember the any equipment. Okay, if excess current flows it will be overheated, it loses insulation and it leads to a reduction in the life of the equipment. You have observed overhead lines, right? Pole A, pole B. So if the overhead line passes too much current, what happens? The conductor lengthens, okay, and sag of the catenary increases. So here sag. So distance between the ground and the cable, it will become less, that we call it as a clearance. Okay, clearance to the ground is reduced. sag of the quaternary increases. So you can observe here. Okay. So any reduction in the clearance of an overhead line to the ground, that will lead to consequences both for an increase in the number of faults but also danger to public safety also. If the overhead wire is near to the ground, then that will be affected to the people. Okay, that will be a danger to the public safety. So thermal constraints mainly depend on the environmental conditions that can change through the year. Next is the operational constraints. So you can observe here, power system operates within prescribed voltage and frequency limits. Operational constraints means, remember, voltage and frequency limits. So if excess voltage, that is voltage, exceeds its upper limit, then it will lead to a short circuit fault. Okay, insulation of components of the power system and the consumer equipment may be damaged, that will lead to a short circuit faults. Excess voltage, if excess voltage, what happens, equipment will be damaged and it leads to the short circuit faults. If it is less voltage, then what happens, may cause malfunction of customer equipment and that will lead to a excess current. If low voltage is there, that will lead to a excess current and tripping of some lines and generators. So the capacity of many traditional distribution circuits is limited by the variation in voltage that occur between times of maximum and minimum load, and so the circuits are not loaded near to their thermal limits. Distributed generation can cause over voltage. When you will get the over voltage? During a light load. Okay, when you will get under voltage? During the heavy load. So thus requires coordinated operation of local generation, on-load tap changes and other equipment used to control the voltage in distribution circuits. So in operational constraints, remember, voltage and frequency limits, over voltage, that is a upper limit and lower limit. Upper limit leads to short circuit faults, lower limit leads to the tripping of some generators, tripping of lines and generators. Here over voltage during light load, and it requires a coordinated operation of the local generation in order to control the voltage level in the distribution circuits. So system operators maintain the frequency within a strict limits. When it varies, response and reserve service are called upon to bring the frequency back within its operating limits. Okay, under emergency conditions, some loads are disconnected. During emergency conditions, some loads need to be disconnected to maintain the stability of the system. So voltage, frequency, that is upper limit voltage, lower limit voltage and over voltage, and here maintain the frequency. And next, under emergency conditions, some loads are disconnected to maintain the stability of the system. Next, power system operators increasingly seeking frequency response and reserve services from the load demand. In future, the electrification of domestic heating loads and electric vehicle charging will lead to a greater capacity of flexible loads. This would help maintain network stability. So here, in future, electrification of domestic heating loads and electric vehicle charging, that will help to maintain a network stability. Fourth is a security of supply. So modern society requires a increasing reliable electrical supply as more and more critical loads are connected. So a smart grid approach is to use an intelligent post-fault reconfiguration so that after the faults in the power system, the suppliers to customers are maintained, but to avoid the expense of multiple circuits that may be only partly loaded for much of their lives. Fewer redundant circuits result in better utilization of assets but high electrical losses. So traditional approach to improving reliability was to install additional redundant circuits at considerably capital and environmental impact. This is about the security of supply. National initiative. Many national governments are encouraging smart grid initiative as a cost-effective way to modernize their power system infrastructure while enabling the integration of low carbon energy resources. Nowadays you can observe for solar power installation they are giving incentives. They are encouraging the solar installation to the homes. They are giving incentives in order to reduce the carbon energy resources. Okay, so here they are more concentrating on renewable energy sources. So here development of the smart grid is also seen in many countries as an important economic or commercial opportunity to develop a new products and services. For example, China, European Union, Japan, UK, USA. So in national initiatives you can write regarding incentives they are giving for renewable energy sources, that is solar. Okay, you can write it in on own. Okay, because national governments always encourage for smart grid initiatives, okay, as a cost effective way to modernize the power system, like the smart home. Okay, smart home means it will be all the smart appliances, cost energy consumption will be less, and the rooftop the solar should be used, and hybrid vehicle. Okay, electric vehicle, plug-in hybrid electric vehicle. So smart home using energy consumption, less energy consumption equipments. Okay, so smart home incentive solar installation. So these will be national governments because they encourage for this. Okay, remember, modernizing their power system infrastructure while enabling the integration of low carbon energy resources, that is what solar, wind, hydro, those are low carbon energy resources.